Write down alkynes. Alkene completed. So next topic continuation, alkynes. Right. So what are alkynes? What are alkynes and preparation property? Here also, like similar to alkane, alkene. In alkyne topic, most important is equation, preparation properties. In all hydrocarbons, you need to have a separate note. I told you beginning. Particularly for hydrocarbon preparation, like alkene. How many preparation are there? 1, 2, 3 equations, properties. Hardly 2, 3 properties. If there is any named reaction separately. If there is any reagent separately. That's finished. So questions also most of the time comes based on equations. Okay. So here also same thing we need to follow here. Preparation properties are most important. But before going preparation properties, we have 3 important properties of alkyne. 1, structure. 2, nomenclature, isomerism. Right. So structure, nomenclature, isomerism, then preparation, then properties. Tell me. So what are alkynes? What is the definition of alkyne, or what are alkynes? Unsaturated hydrocarbons having carbon-carbon triple bond, right? So therefore unsaturated hydrocarbons having carbon-carbon C triple bond C called alkynes. Then what is the general formula of alkyne? So general formula is CnH2n minus 2, where n is equals to number of carbon atoms. Okay, then get in. Next is structure of alkyne. Tell me. So to understand the structure of any organic compound or any molecule, we study first hybridization. What is hybridization? Then what is lone pair? Then what is the geometry? Okay, so therefore hybridization, lone pairs are important to understand structure and geometry. So therefore tell me, let us take example for alkyne is, I'll take smallest or simplest alkyne is ethine. Right, it is a ethine, and moreover its common name is acetylene. So here onwards we use this name is very popularly, very commonly, acetylene, CH triple bond CH. Can you tell me now what is the hybridization of carbon in acetylene or any alkyne? So if carbon has single bond sp3, carbon has double bond sp2, carbon has single bond is sp. Therefore hybridization is sp. And is there any lone pair electron? No, there is no lone pair electron. Therefore hybridization is sp, lone pair is 0. Then what is expected geometry? Geometry of the molecule is linear. Right, this information we study in chemical bonding. Hybridization sp, lone pair 0, so expected geometry is linear. Okay, then when comes to structure, carbon-carbon bond length and carbon-hydrogen bond length and bond angle also important. Tell me, what is the carbon-carbon bond length? It is 1.20, okay, 120 or 1.20 angstrom. In picometer, 120 picometer. Right, next is carbon-hydrogen bond length, 1.06 angstrom or 106 picometer. Next, what is the bond angle? Since it is a linear, bond angle is 180 degrees. Okay, but here one important information is about acetylene. We know that acetylene is a CH triple bond CH Of course, it is a linear molecule like this. It is a linear molecule having 2 carbon and those 2 carbon also sp. Okay, and it is a sp carbon. Due to sp carbon, these 2 carbon lies on the plane and 2 hydrogen also lies on the plane. Okay, and the structure of this particular molecule is, it is look like cylinder, hence it is called cylindrical structure. So remember, acetylene has, not other alkynes, only acetylene has cylindrical structure. For example, if you take propine, is it propine has cylindrical structure? Of course linear. It is a linear but not cylindrical. Why? It is not cylindrical because not till here all the atoms are present same plane, but this is sp3. Due to sp3 carbon, on this carbon there are 3 hydrogen, 1 hydrogen above the plane, 1 is below the plane, another is on the plane. So that means 3 atoms are present in different plane. It doesn't become a cylindrical. You can say linear. So this molecule is linear and it is a linear, you cannot say this is tetrahedral. This part is tetrahedral but the remaining part is linear. Therefore it is called linear only, not tetrahedral. Right? So this is not a cylindrical. So cylindrical structure is only for acetylene. Okay. So this is about the structure of alkyne. Next, second point is about nomenclature. We studied nomenclature very detailed in nomenclature topic, nomenclature of alkyne. Go to class. Okay, so it is CH triple bond CH. Tell what is this? Ethine, CH3 C triple bond CH. This is propine, CH3 CH2 C triple bond CH. Now tell me, this is what? Butane. Which butane? It is a but-1-ine. Next, can you write but-2-ine? So numbering 1, it is 2, 3, 4. This is but-2-ine. So like that, many more example written. Suppose if there is a substituent present here and triple bond present, ending, then tell me numbering should be either from the substituent or multiple bond. Multiple bond, no. Double bond, triple bond should be considered as a functional group. Double bond is more than triple bond. In the priority order of functional group, we will write in the priority order double bond then triple bond. Therefore, double bond, triple bond comes under functional groups only. 1, 2, 3, 4, 5. So what is the IUPAC name? 4-chloro-pent-1-ine. So 4-chloro-pent-1-ine. Next, if there is a double bond, triple bond present on the same positions from the two end, tell me, numbering should be start from the double bond, triple bond. Double bond. So double bond has more priority. 1, 2, 3, 4, 5. Therefore, this is a pent. Now, shall we write first ene or ine? It is according to alphabetical order. Ene come first. Which ene? 1 ene, ene. Only en. Which ine? 4 ine. Right. So if the secondary suffix starts with a, e, I, o, u, y from the primary suffix, remove the last letter e. That is the rule. Like that, we have written many more examples. You practice IUPAC nomenclature. Once again, questions are important. Okay. Next is isomerism. So isomerism also we have studied topic very in detail. Tell me, we have studied isomerism of alkene. Do you remember? Alkene can exhibit which isomerism? 1. Structural. 2. Geometrical. It comes with structural, no? Structural. 2. Geometrical. 3. Optical. Yes or no? So structural, geometrical, optical, these three isomerism we have studied where? Alkene. Now tell me, alkyne. Alkynes can also exhibit same isomerism except geometrical. Geometrical isomerism is a property of alkenes and cycloalkanes, not triple bond. If there is a triple bond, will you write cis trans? No. Therefore, here what are the isomerism possible in case of alkyne? 1. Structural and second one is optical. So therefore, there are two types of isomerism possible. 1. Structural isomerism and another one is optical. Can you tell me structural isomerism again? Which type of isomerisms are possible in structural? It is just like alkene. In alkene also we have studied same. 1. Chain isomerism. 2. Positional isomerism. 3. Ring chain isomerism. 4. Functional isomerism. These 4 isomerism we have studied alkene. Okay, we are not studying new concepts. Everything we have studied in alkene topic. The same thing I am writing here. So tell me, 1. Chain isomerism. 2. Positional isomerism. 3. Ring chain isomerism. And 4. Functional isomerism. So these 4 isomerism also possible in case of alkene. We have studied same. Next, second one, structural, then stereoisomerism. So alkyne can also exhibit stereoisomerism, which is having at least one asymmetric carbon. That is a condition. Okay. So therefore, now tell me, in structural isomerism, first one, chain isomerism. Chain isomerism. What is chain isomerism? Already we have studied definition and all. Do you remember? So what is chain isomerism? The organic compound which are having same molecular formula but they differ in either parent chain or side chain. Molecular formula should be same. They must be differ either in side chain or parent chain. Next, positional. Organic compound which are having same molecular formula but they differ in position of the triple bond here. Position of triple bond. Next, ring chain. The organic compound which are having same molecular formula but they differ in what? One is a ring, other should be a open chain. Ring chain. Same molecular formula, they should be differ in mode of attachment. Mode of attachment of carbon-carbon. One is a open chain, another one is a cyclic ring. Next is functional. Here organic compound which are having same molecular formula but they should have different properties. Functional group. Here, can you tell me example for functional isomerism here? Alkynes are example for functional isomers with what? Tell me. Very good. Alkyne, C triple bond C, no? So alkynes are functional isomer with alkadienes. Alkynes, alkadienes, both are having same molecular formula. One is a ine, another is a diene. They are example for functional isomers. Okay. Now tell me example here, chain isomerism. For the chain isomerism, can you tell me minimum number of carbon atom is required for chain isomerism? In case of alkane, alkene 4, but in case of alkyne 5. I'll tell you why. For example, if you take 4, CH3, CH2, C triple bond C H. Okay. How many carbon atom ring has, chain has? 1, 2, 3, 4. The parent chain has 4 carbon atoms. Now, can you write another alkyne with 3 carbon atoms? If I want to write, I must write like this. This is one possibility now. Here should be CH3. Is it possible? It is not possible. It means, so for to exhibit chain isomerism, alkynes minimum, alkyne must have minimum 5 carbon atom. 4 carbon atom is not possible. 4 carbon atom possible for what? Alkane and alkenes. Okay, that's what, that is not possible. For 5 carbon atoms you can write it CH3, CH2, CH2, C triple bond CH. Okay, it is a 5 carbon. You can write 4 carbon. 1, 2, 3, 4. 4 carbon. It is a 5 carbon. Same molecular formula. They must be different in what? Either it should be parent chain or side chain. So I can go on, write many more example. Next, second one, positional isomerism. Positional. Tell me. So what is a positional isomerism? Organic compound which are having same molecular formula but they differ in what? Position of multiple bond. Here triple bond. So they should be differ in the position of triple bond. For example, CH3, CH2, CH2. Okay, you can take it is. It is a but 1 ine. You can also write but 2 ine. So but 1 ine, but 2 ine are example for positional isomers. Next, ring chain isomer. Ring chain. Tell me, which organic here? Alkynes are ring chain isomers with what? Alkynes are ring chain isomers with cycloalkenes, because alkynes and cycloalkenes are having same molecular formula, but one is a cyclic ring, another is a open chain, ring chain. So therefore here alkynes and cycloalkenes, so both are having same molecular formula CN H2N minus 2. For example, let us take butane. So butane and cyclobutene. So butane, cyclobutene both are having same molecular formula. Okay, one is a open chain, another is a cyclic ring. So here important is this, alkynes and cycloalkenes are ring chain isomers. Next, fourth one, functional isomerism. For functional isomerism, alkynes are the functional isomers of what? Which organic compound? Alkynes and alkadienes. So alkynes and alkadienes both are having same molecular formula. One is a alkyne, another is a diene. For example, let us take, it is a but 1 ine, comma but 1 ine and butadiene. You can take butadiene. But 1 comma buta 1 comma 3, no, dienes. So but 1 ine and buta 1 comma 3 diene. We shall write buta, right? Buta when there are 2 double bond. Buta 1 comma 3 diene. So our example for functional isomer. There was a previous question, CET question, write down question. Butane. But1-ine is a functional isomer of. But1-ine is a functional isomer of 1. But1-ine is a functional isomer of 1. But2-ine. 1. But2-ine. 2. Buta 1, 2 diene. Buta 1, 2 diene. 3. Buta 1, 3 diene. 4. 2 and 3. Tell me answer. But1-ine is a functional isomers of what? But 1, 3 diene. Why not but 1, 2 diene? Huh? That is also no. One is a triple bond, other one is a diene. Alkynes and dienes. It may be 1, 2 diene. It may be 1, 3, 1, 4, any diene. We did not tell that only this diene are like functional isomers. Not. Alkyne or any dienes are example for their functional isomers. Therefore, butane. It may be but1-ine, but2-ine. Butane and buta 1, 2 diene, buta 1, 3 diene, both are example for functional isomers. Now one more question. No, don't write. Same question. But1-ine and but2-ine are example for what? But1-ine, but2-ine are example for positional isomer. They differ in the position of triple bond. Okay. So this kind of question can be expected. So it is about isomerism. And last one is stereoisomerism. In stereoisomerism, alkyne can exhibit only optical isomerism. Okay. So optical isomerism we have studied in detail. Can you tell me what is the condition for optical isomerism? Organic compound must have chirality, not chiral carbon. Okay. For optical isomerism, molecule must have chirality. Right. When you say molecule have chirality, if molecule do not have 2 or 3 element of symmetry, one plane of symmetry, center of symmetry and alternating axis of symmetry. If molecule do not possess three elements of symmetry, then molecule said to be a chiral molecule. It is optically active. But in our syllabus, the majority question comes on chiral carbon. But here see, then how to identify the molecule is optical active or optical inactive. So remember, if any molecule has only one chiral carbon, if there is only one chiral carbon, it is 100% optically active. If molecule has 2 or more chiral carbon, then we need to say plane of symmetry. If there is a plane of symmetry, we need not to see other 2 element of symmetry. There is optically inactive. Therefore, majority questions are one chiral carbon. Okay. So then there are some molecule which do not have chiral carbon, but they are optically active. Example, we have studied biphenyls, right? We have studied styrene. Okay. Cycladienes. Example studied, no? So that concept is different. Now tell me here, if alkyne having one chiral carbon, it is optically active. Then for that condition, tell me, if it is a carbon, it is having like a ethyl group, another side is methyl group, another side is you can take ethine, that is a alkyne, and another side is hydrogen. Now question is, can you write optically active alkyne with less than this carbon? ಇದಕ್ಕನ್ನ ಕಡಿಮೆ ಕಾರ್ಬನ್ ಇಂದ ಆಪ್ಟಿಕಲಿ ಆಕ್ಟಿವ್ ಆಗುತ್ತಾ? No. This is a chiral carbon, right? This chiral carbon has methyl, it is a ethyl, it is a ethynyl, then hydrogen. It means 1, 2, 3, 4, 5, 6. The minimum number of carbon atom should be how many? 6. Therefore, same thing we have studied in case of alkene also. For alkene and alkyne, to exhibit optical isomerism, minimum carbon required is 6. Whereas in case of alkanes, 7. Because in case of alkane, if you take ethyl, you cannot take 2 carbon here. You must take 3 carbon. So alkane ಆದರೆ 7 carbon ಬೇಕಾಗುತ್ತೆ. Alkene, alkyne ಆದರೆ 6 ಬೇಕು. Yes or no? Are you okay? Not. Not feeling well. Okay. So this is about optical isomerism, right? Next is methods of preparation of alkynes. Methods of preparation of alkynes. So what are the methods of preparation of alkynes? 1. I'll write the list of methods. First one, this is we have studied dehydrohalogenation of vicinal dihalide. Dehydrohalogenation of vicinal dihalide. 2. Dehalogenation of 1,1, 2,2 tetrahaloalkane. 3. Hydrolysis of calcium carbide and magnesium carbide. 4. Laboratory method of preparation. 5th, Berthollet synthesis. 6. Sixth one is from sodium acetylides, and 7th one reaction between haloform and silver, and 8th one already we have studied, electrolysis. Electrolysis of sodium or potassium salts of dicarboxylic acids. Okay. So these are the methods of preparation of alkynes. Now see, so first one, dehydrohalogenation. This is we have studied preparation of alkene. So what is the meaning of dehydrohalogenation? The process of removal of hydrogen and halogen. Can you tell me what is the reagent used? Very good, alcoholic KOH. And dehydrohalogenation, it is an elimination reaction. It is of how many types? 3 types, E1, E2, E1CB. Okay, fine. Next is dehalogenation. So what is the dehalogenation? Removal of halogen. So therefore, how do you remove the halogen? By using, very good, zinc metal, right? So when it is dihaloalkane or tetrahaloalkane heated with zinc metal, so it is a dehalogenation takes place. That is also we have studied. And hydrolysis of calcium carbide, many time question appeared in different exams. And recently in CET it asked calcium carbide, magnesium carbide. So calcium carbide, magnesium carbide undergo hydrolysis, they form alkynes. Next, laboratory method. This is a simple method, Berthollet method, from sodium acetylide. Okay, that we study. And this is we have studied electrolysis of sodium or potassium salt of dicarboxylic acid. One second, sodium potassium salt of unsaturated, right? Better. Then it becomes clear. Unsaturated dicarboxylic acid. Do you remember this method we have studied in alkane, even alkyne also, right? During preparation of alkene we have studied this also. Then to prepare alkane, which carboxylic acid taken? Monocarboxylic acid. To prepare alkenes, dicarboxylic acids. Yeah, saturated dicarboxylic acid. To prepare alkynes, unsaturated dicarboxylic acid. That is the difference. Okay, byproducts are same. So questions also same. What is the product at cathode? What is the product at anode? What is the nature of the solution? Resulting solution. Those questions are similar. So hardly 3-4 equations we have not studied. Remaining all we have studied. Right. Let's see. First one. Dehydrohalogenation of vicinal dihalide. See, dihalides are two types, vicinal and geminal. So what are the vicinal dihalide? If halogen present on adjacent carbon, alpha beta carbon, adjacent carbon called vicinal dihalide. If halogen present on same carbon, that is called geminal or gem dihalide. Okay, now let us take it is a vicinal dihalide. This method we have studied preparation of alkene. Here alkyne can also be prepared, but difference is there we take monohaloalkane, here is dihaloalkane. Right, it is a dihaloalkane. So remember, alcoholic KOH is a dehydrohalogenating agent. Tell me, this alcoholic KOH, whether it is E1 or E2 possibility. E1 or E1, E2 E1. Alcoholic KOH is E1, sodium ethoxide or sodium alkoxide is E2. Remember reagent. Okay, in E1 elimination, what is the intermediate? Carbocation. In E2 elimination, no carbocation, that is a transition state. Fine. Now tell me, both E1, E2, all elimination takes place according to Sergeff rule. E1, E2, E1, CB, everything no, all three takes place according to Sergeff rule. Now tell me, here halogen, I'll take alpha carbon, it is a beta carbon. So how dehydrohalogenation takes place? Remove the halogen from alpha carbon, hydrogen from beta. Therefore it become CH2. CH2 become CH and Cl will be there, double bond CH2. Okay. Then H and Cl, HCl is eliminated. HCl plus KOH, what do you get byproduct is? KCl plus water. You are written now. Now, but still there is another chlorine and here alpha hydrogen, beta hydrogen is there. Now for this dehydrohalogenation, this is a alpha carbon, now this is beta carbon. Now remember, to remove one hydrogen halogen, we take alcoholic KOH. Now to remove another dehydrohalogenation, we do not use alcoholic KOH. We use still stronger dehydrohalogenating agent, that is a soda amide, important. Soda amide also one of the dehydrohalogenating agent. In presence of soda amide, so another halogen here, hydrogen here is eliminated, it become this. Okay, then in exams and all, this question will be given like this: CH2Cl, CH2Cl, and here first reagent is alcoholic KOH and second reagent is soda amide. What is the product? That is acetylene, right? Acetylene. Okay, but here the byproduct are changes. Can you tell me what is the byproduct here? H and Cl, HCl. This HCl plus KOH, KCl plus H2 are the byproducts. Then what are the byproduct here? It is Na plus NH2 minus. NH2 minus H plus NH3, then Na plus and Cl. Yeah. So therefore byproduct changes by using these two reagents. Okay. Then next is, since it is a elimination reaction, we know all elimination takes place according to Sage-Jaffe rule. Therefore it is takes place according to Sage-Jaffe rule. So we know that Sage-Jaffe rule is poorer become poor. Okay. Then you just write the product CH3 CH Br CH2 Br 1 alcoholic KOH 2 sodium amide. What is the difference between alcoholic KOH and aqueous KOH? Alcoholic KOH is a base, aqueous KOH is a nucleophile. Alcoholic KOH elimination, aqueous KOH substitution. Which substitution? Nucleophilic substitution. Write the products. Tell me here. It is CH3 C triple bond CH. Here CH3 triple bond C CH3. Okay. Tell me. Now this is a alpha carbon, beta 1, here hydrogen, here 2 hydrogen, it is a beta 2. Tell me. Huh? So from the beta 2, think once. If hydrogen eliminated from beta 2, you will get double bond here. Okay. And if it is removed here, double bond here, which is stable. Beta 1 stable, because say if hydrogen eliminated from beta 2, this already double bond is there, you will get another double bond here. It means this carbon becomes what? sp carbon. But sp carbon should be what? Linear. sp carbon should be linear. But will you get linear here? No. In order to get linear, this bond should be broken. Molecule do not exist. Right? Do you understand? That means in cyclic ring, cumulative double bonds are not possible. Means continuous double bonds. In the cyclic ring, if the continuous double bond present, this carbon supposed to be sp and it's supposed to be linear. In order to get linear, it should be break. This bond should be broken. Broken. Then that is not possible. Therefore, this is not possible. And moreover, if one hydrogen removed here, it become what? Aromaticity. Because of aromaticity, it can lose hydrogen, beta 1 hydrogen easily. Okay, so that means this is against Kirchhoff rule. In these conditions, wherever stable molecule is formed, so there Kirchhoff rule is not allowed. Okay, next is second method of preparation, dehalogenation of 1, 2, 1, 1, 2, 2 tetrahaloalkane. So dehalogenation of 1, 1, 2, 2 tetrahaloalkanes. So what is the meaning of 1, 1, 2, 2? On one carbon there should be a 2 halogen, adjacent carbon also there should be a 2 halogen. Okay, for example CH, Cl, Cl, CH, Cl, Cl. Now this is a 1, 1, 2, 2 tetrahaloalkane. Now tell me, we know that dehalogenating agent, that is a zinc. Zinc followed by heating. Now how many moles of zinc should be taken? 2 moles, because 1 mole of zinc can remove, so 2 chlorine. So another mole of zinc, it also removes 2 chlorine, right? So by removing 2 chlorine, 1 bond, here another bond, CH, triple bond CH, plus how many moles of ZnCl2? 2 moles of zinc chloride. Then same reaction we have studied in the preparation of alkene. How? We have taken 1, 2 dihaloalkane. It is a tetrahaloalkane. That is the difference. There we removed 1 mole of ZnCl2 byproduct. Here 2 moles of ZnCl2. Okay. Next, one more example. You just write the product. Usually this method require heating. In all elimination reactions, heating is required. Whether less or more, usually heating required. Okay, so here triple bond comes here triple bond comes. Next, third method of preparation is hydrolysis of calcium carbide and magnesium carbide, Mg2C3. So this was the previous CET question. So hydrolysis of calcium and magnesium carbides. Tell me, calcium carbide CaC2 undergo hydrolysis. So there are how many carbon? 2 carbon. So 2 carbon gives 2 carbon alkyne, that is acetylene. Okay, and calcium plus water you will get calcium hydroxide. But here important is what is the structure and how reaction takes place. So 1 calcium it is linked with 2 carbon. This is a cyclic molecule, calcium carbide. Okay, in carbide topic you have studied metal carbide, ionic carbides. It is ionic carbide, right? Ionic carbide, calcium carbide, which is reacts with water, H2O. We know that H2O produces H plus plus OH minus. Now here it is a plus 2 minus 1 minus 1. This bond is broken, H plus added here, OH here is H plus, this side is OH minus. CaOH OH, it becomes what? CaOH twice. CH CH CH, it becomes C triple bond H. Okay. So therefore calcium carbide on hydrolysis gives, name also important, formula, calcium carbide on hydrolysis acetylene is formed. Next, magnesium carbide, it is Mg2C3, magnesium carbide. This magnesium carbide is, there are 3 carbon, 2 magnesium. This is not cyclic, it is not a cyclic carbide, which is reacts with water. You see 3 carbon. So 3 carbon alkyne is propine. So therefore it gives propine, and there are 2 magnesium, you will get magnesium hydroxide. So calcium carbide gives acetylene, magnesium carbide gives propine. Do you remember the same method of preparation we have studied alkane? Which carbide on hydrolysis gives methane? There is a preparation of methane. Which carbide on hydrolysis gives methane? See the notes. Tell me. Sodium carbide. No. Preparation of alkene, aluminum carbide. Another one is beryllium carbide. Aluminum carbide, beryllium carbide gives alkane. In alkene we have not studied any carbide. This is alkyne. You should remember it. So it is a method of preparation. So this question was given in CET in the interconversion. I will give the equation later. Question. Next is 4th method of preparation is 4th one is laboratory method. So how do you prepare alkyne in laboratory? It is by combustion of methane. Methane undergo oxidation. It is a partial oxidation. It is at 1500 degrees Celsius. In laboratory, acetylene can be prepared. Okay. Apart from this, it gives water also. So here condition is it should be 1500 degrees Celsius. Next, 5th one is Berthollet synthesis. The scientist called Berthollet has prepared the acetylene from the carbon. Carbon just treated with hydrogen, it is at 1200 degrees Celsius, which gives rise to acetylene. Only equations are important, which is called Berthollet synthesis, carbon plus hydrogen. Next, 6th method of preparation. From sodium okay, this is also previous question which was given in NEET. From sodium acetylide. Okay, let's see what is sodium acetylide. We know acetylene, which is reacts with sodium metal. Tell me, Do you know the property of the metal is, usually metals reacts with dilute acid. Any dilute acid, they liberate hydrogen gas. So we have studied in electrochemistry. In electrochemistry, we have studied one statement: the metal with negative SRP, means below hydrogen in electrochemical series. Yes, the metal with negative SRP below hydrogen electrochemical series reacts with all dilute acid, they liberate hydrogen gas. Now here also sodium metal negative SRP, which is reacts with acetylene. Now tell me, sodium plus acetylene, here one hydrogen replaced one sodium, CH triple bond C Na, which is called sodium acetylide, plus half H2. This sodium acetylide, it is having another hydrogen, it is also reacts with another mole of sodium metal. So this hydrogen replaced by sodium, which gives rise to disodium acetylide, plus of course half hydrogen gas is liberated. Now tell me, this reaction shows what? This reaction indicates acetylene is acidic nature. Yes or no? Because acid only liberate hydrogen gas, no? If any compound is liberating hydrogen gas with sodium, that must be acid, acidic nature. Therefore, this reaction indicates acetylene is a acidic nature. Okay. Now tell me, since acetylene is acidic nature, can we write like this? CH triple bond CH, which produces one proton. Okay, it is a acid. We know that acid always produce what? Conjugate base. And this is also having another proton. It gives us to another proton, right? Yes or no? So therefore, it is actually dibasic acid. This reaction shows acetylene is a dibasic. So what is the meaning of dibasic? Which produce two protons. So therefore, acetylene is a dibasic acid which is capable to produce two protons, like sulfuric acid, dibasic. Okay. Now our question is, we are preparing the alkynes. We are preparing alkyne from where? Sodium acetylide. So therefore, here let us take sodium acetylide, which is reacts with any alkyl halide. You can take RX, any alkyl halide. Then sodium and halogen is removed as a NaX. Then the product is what? Which is called higher alkynes. That is, you can prepare the higher alkynes from what? Acetylene. First we have to convert acetylene into what? Sodium acetylide. That sodium acetylide further reacts with any alkyl halide, which gives a higher alkynes. Okay. Now one example. Let us take CH triple bond C Na, which is reacts with methyl chloride. You write the product. Next, CH NaC triple bond CNA, which is reacts with 2 moles of ethyl bromide. Write the product. Here you remove 1 chlorine, 1 sodium. Here sodium, 1 ethyl, sodium, another ethyl. So higher alkynes can be prepared easily. Seventh one. What is the seventh one? Reaction between haloform and silver metal. It is also previous NEET question. Reaction between haloform and silver metal. So reaction with a reaction between haloform. Can you tell me what is haloform? Anybody? Haloform is CHX3. So CHX3 may be what? CHCl3, CHBr3, CHI3. This is a chloroform. It is bromoform, it is iodoform. So therefore alkyne can be prepared by using any one of this haloform. Okay, then silver metal. How? So reaction is so simple. Let us take, it is CHX3, 1 mole and 6 mole silver. Take another haloform. So 2 moles of haloform, you just remove the X3. There are 6 halogen, 6 silver. What it forms? 6 AgX, right? You will get acetylene. This method is used to prepare only acetylene, not any other alkynes. Yes or no? For example, chloroform. CHCl3, 2 moles, 6 silver. Write the product. CHBr3, 2 moles, 6 silver. The ratio of haloform and silver is, what is the ratio? 1:3. 2, 6, no. Ratio should be 1:3. Okay. So write the product here. In both the case, acetylene. So electrolysis of sodium or potassium salt of unsaturated dicarboxylic acid. So example, this is we have studied in geometric isomerism. Do you remember? In place of potassium, if I write hydrogen, it become what? Malic acid. Very good. Malic acid cis, fumaric acid trans. The relation between malic acid, fumaric acid is cis trans isomers. Okay. So this is a potassium salt of malic acid. Okay. And tell me, it is undergo electrolysis. Then how to write product? Or what are the product? Tell me first. So bond is cleave here, bond is cleave here. It becomes what? CH triple bond CH acetylene and CO2, 2 moles of CO2 formed, and this potassium and water will be there, no, electrolysis. So potassium plus water, you will get potassium hydroxide plus potassium plus water also produces hydrogen gas. Metal plus water. Yes or no? Now tell me here. So what are the product at cathode and anode? Tell me which product is obtained at cathode? Rajeshwari, product at cathode. Cathode is high. Anode is. So the product at cathode is hydrogen gas, no? H plus. It is at cathode, and at anode alkyne, acetylene, and CO2 also. And KOH is, it is actually K plus combined with OH minus. KOH is formed. Then what is the resulting solution? Basic. pH is greater than 7. Okay. So mechanism is everything same. In alkene topic we have written. So need not write once again. So these are the methods of preparation of alkynes. Okay, properties of alkyne. In properties of alkyne, we study first physical and chemical property. Physical property, there are 3 physical property are important for organic molecule. 1 is physical nature, 2 melting point, boiling point, 3 solubility. But in fact, the physical nature of alkane, alkene, alkyne, not exactly but almost similar. Okay, let's see one physical nature. So what is the physical nature of alkyne? So usually 2, 3, 4, C2, C3, C4, these 3 are the colorless gases. Means ethine, propyne, butane. Is it methane possible? 1 carbon alkyne. Idya? Illalma. Okay, ನೀವು ಪ್ರಿಪೇರ್ ಮಾಡಕ್ಕಷ್ಟೇ. ಯಾರು ಪ್ರಿಪೇರ್ ಮಾಡಿಲ್ಲ ನೀವು ಮಾಡ್ಬೋದು. So ethine, propyne, butane. So these 3 are the first 3 are alkynes, gaseous nature. Okay. Next, then what about 5 and 6? C5, 6, they are usually they are liquids. Which kind of liquids? Liquid ಅಲ್ಲಿ ಕಂಡಿರುತ್ತಾ? ಯೂಶುವಲ್ ಲಿಕ್ವಿಡ್ ತಾನೇ. Okay, then in case of alkane is different. Till 17 carbon you will get liquids. Here usually 5, 6 are liquids, and 7 and above, C7 and above carbon, they are wax like solid. Okay, then you may have doubt, why 6 only 7, 5, 6 only liquid, why not till 17? See, when you compare alkane, alkene, alkynes having more polarity, right? The polarity of alkyne is more compared to alkene and of course alkane also. So therefore due to polarity they are having more force of attraction in between the molecule. Due to more force of attraction, so here 5, 6 become liquid, and more than 6 it becomes solid. They exist like, say, what is a wax like solid. It's not like wood solid, not very strong. It is soft solid, wax like solid. Okay. Next is melting point, boiling point. Melting point, boiling point also has not much important. It is important particularly alkane. Melting point, boiling point of alkane is very, very important. Even alkene has not that important. Here, when you compare the melting point, boiling point, the melting point, boiling point of alkyne is more compared to alkene. Of course, alkene is more compared to alkane. condition is same number of carbon atoms. Okay, so why alkyne melting point, boiling point is more compared to alkene? Anybody? Because of same reason, polarity. So alkynes having more polarity, for example CH triple bond CH. So therefore it is a proton, no? Acidic proton, it becomes negative, no? This is a positive, this is positive. It has more polarity. Due to more polarity, it can produce acidic proton. So that's what usually, and moreover, it is sp carbon, more electronegative. Due to more electronegative sp carbon, it becomes more polar. So therefore, the overall conclusion is alkynes having more melting point boiling point compared to alkenes because of more polarity. Okay. Then as the number of carbon atom increases, melting point boiling point is increases. That is same. As the branching increases, melting point boiling point decreases. That's same. Okay, like alkane only. Next, solubility. When comes to solubility, usually these are insoluble in water. They are not soluble in water usually because they are organic molecule. They are soluble in where? Polar solvent, organic solvent. But when you compare the solubility of these alkyne is more compared to alkene and alkane. More andre matte complete soluble agalla comparatively. Otherwise it is we can say insoluble in generally. Okay. So therefore you write one sentence enough. Melting point, boiling point. The melting point, boiling point of alkyne is more than alkene. Alkene is more than alkane. Similarly, they are actually insoluble. When you compare solubility, alkynes are little soluble compared to alkenes. Okay, so it is about physical properties of alkynes. Okay, then chemical properties. Chemical properties. Chemical properties. See, take 2 minutes break. I want to tell you something. Break and book. Okay, see, listen here. Chemical properties of alkynes. Right, see, chemical properties of alkane we have studied, alkene we have studied. See, the chemical properties of alkyne similar to alkene because of carbon-carbon multiple bond. Okay, so therefore, here in case of alkynes can undergo two type of chemical reaction, or it is due to two reasons. One, chemical properties due to presence of acidic hydrogen. Okay, so because alkynes having acidic hydrogen, so due to presence of acidic hydrogen, alkynes can undergo like particular reactions. Next, second is chemical properties due to presence of carbon-carbon multiple bond. Right. So due to presence of carbon-carbon multiple bond, alkene can undergo which reaction? Electrophilic addition. Here also we study same. Along with electrophilic addition, we have some other reaction like oxidation, polymerization, etc. So therefore, chemical properties of due to two reasons. One, chemical reactions or reactions due to reactions due to presence of reactions due to presence of acidic hydrogen, And second one is reactions due to presence of pi bond. Right. So due to presence of pi bond and due to presence of acidic hydrogen, so they undergo different reactions. Let's see first one. Right, reactions due to presence of acidic hydrogen. Here, which reaction comes in this category? So already we have written one, or A, reaction with sodium metal. Yes or no? Sodium metal reacts with what? Acids only. Therefore, one, reaction with sodium metal. B, reaction with liquid ammonia. C, reaction with soda amide. So these three are similar: sodium, liquid ammonia and sodium. Okay, so reaction with sodium metal, reaction with sodium liquid ammonia and sodamide. In three cases, sodium replaces the hydrogen. Next, D, reaction with ammonical silver nitrate solution, which is called, very good, Tollens reagent. This is very, very important. Many time question was appeared. Reaction with ammonical silver nitrate. It means it is AgNO3 plus ammonium hydroxide, which is called Tollens reagent. And D is reaction with ammonical cuprous chloride, Cu2 Cl2. Me the class this one. Okay, so reaction with ammonical Cu2 cuprous chloride. See, all reactions are exactly similar. These two questions are many time question was appeared. I'll tell you where this question, see. Do you remember? Reaction with ammonical silver nitrate solution. Ammonical silver nitrate solution is called what? Tollens reagent, right? Tollens reagent. Usually where the Tollens reagent is used? Very good, aldehydes. In the conformation test for aldehyde, only aldehydes can react with the Tollens reagent. They form the silver mirror or black PPT, which is also called silver mirror test. Silver mirror test for only aldehydes. Along with aldehydes, even acetylene, that is a terminal alkyne. Terminal alkyne or acetylene can also give this test. The previous question is, so Tollens test or silver mirror test is applicable for 1, 2, 3, 4 options. Aldehyde will be there. Along with aldehyde, you will get acetylene. Acetylene also will give this. It is a previous CT question. This was the okay. And this is also previous question. Reaction with ammonical cuprous chloride. So due to presence of acidic hydrogen, acetylene can react with cuprous chloride, where acidic hydrogen replaced by copper, which gives a red PPT. Okay, so these two are very, very important questions. And let's say reaction here. First one, tell me reaction due to presence of acidic hydrogen. Let us take acetylene. Okay, acetylene undergo dissociation, which gives CH triple bond C negative plus H plus. Already we have written. This also gives another acidic hydrogen, which gives this. So therefore this indicate what? Acetylene is acidic nature. It has how many proton? 2 acidic proton. Okay. And now tell me one reaction with sodium metal. Let us take CH triple bond CH reacts with sodium metal. What it forms? This hydrogen replaced by sodium will get CH triple bond C Na plus half hydrogen, which is called what? Sodium acetylide. Sodium acetylide. This sodium acetylide is further reacts with another mole of sodium metal. There is a one more hydrogen replaced by sodium, which is called disodium acetylide, and it also liberates hydrogen gas. Okay. Similarly, for example, if you take propine, propine reacts with sodium metal, it forms it liberate only half hydrogen, right? Now, can it further react with sodium metal? No, it has only one acidic hydrogen. Similarly, let us take butene. Butene reacts with sodium metal. What is the product? No reaction. Yes. Why it is no reaction? No acidic hydrogen. Now question is like this. Which of the following do not react with sodium metal? A, B, C. C. Which of the following is not acidic in nature? A, B, C. C. Which of the following is more acidic? A. These kind of questions. 2 proton, 1 proton, here no proton. Okay, then tell me, now what is the previous CET question? This question is based on this only. It is calcium carbide on hydrolysis gives A. This A reacts with sodium metal, it gives B. B reacts with 2 moles of methyl chloride, C. So what is the IUPAC name of C? Here we need that IUPAC name. Calcium carbide plus water, what do you get? Acetylene. Acetylene reacts with sodium metal, disodium acetylide, which is reacts with 2 moles of methyl chloride. It is a butene. Okay. Sometime they may ask question like this. Equation is like this. IUPAC name of, instead of IUPAC name of C, if they ask C is the product, which is the positional isomer of C? Okay, now option 1, butene, but2ine, but1ine, 1, 2 butadiene, 1, 3 butadiene. Listen question carefully. This is the question given. C is the product. Okay, so C we have written here C this is, but we don't know C what. Okay, C is the product. So which of the following is the positional isomer of C? Which of the following is the positional isomer of C? So to identify the positional isomer, okay, options are 1, butene, but1ene, 1, 3 butadiene, and D is 1, 2 butadiene. So therefore, which of the following is the positional isomer? Second option, because C is what? Butene. So question is not butene. They are not asking this. Its positional isomer they are asking this. So you need to study, read carefully question. ಆ ಕ್ವಶನಲ್ಲಿ ಸ್ವಲ್ಪ ಏನೋ ಚೇಂಜ್ ಇರುತ್ತೆ. ಇದೇ ಥರ ಒಂದು ಕ್ವಶನ್ ಕೇಳಿದ್ದಾರೆ ಹ್ಯಾಲೋ ಆಲ್ಕೇನ್ ಮೇಲೆ. ಪ್ರಾಡಕ್ಟ್ ಈಸ್ ಆ್ಯಕ್ಚುಲಿ ಮಿಥೈಲ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಬರುತ್ತೆ ಇನ್ ದ ಕನ್ವರ್ಷನ್. ಓಕೆ, ಈ ಥರ ABC ಬಂದಾಗ ಮಿಥೈಲ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಬರುತ್ತೆ. ಬಟ್ ಕ್ವಶನ್ ಆಸ್ಕ್ಡ್ ದಟ್ C ಈಸ್ ದ final product. Which of the following is the functional isomer of C? So option is A only first, B is methyl isocyanide. This is answer. Product idu barutte, but question is not asked to product. Isomer of this product, functional isomer, this is the answer. But unfortunately, they give the option first this only. A functional isomer anta nodal now. Interconventional ಬರೆದಾಗ ಲಾಸ್ಟ್ ಆಪ್ಷನ್ ಆನ್ಸರ್ ಬರುತ್ತಾ? ಆ ಖುಷಿಯಲ್ಲಿ ಇದೇ ಆನ್ಸರ್ ಮಾಡ್ತೀವಿ. ಏನು ಖುಷಿ? ಸೊ ಹಾಗಾಗಿ ಕ್ವಶನ್ನು ಚೆನ್ನಾಗಿ ಓದಬೇಕು ಖುಷಿ. ಓಕೆ, ಸೊ ಲೈಕ್ ದಟ್ ಕ್ವಶನ್ಸ್ ವಿಲ್ ಬಿ ಸ್ಮಾಲ್ changes will be there, you need to read carefully. So this was the CET question. Next, reaction with bega, reaction with sodium liquid ammonia. Now this is also same reaction. CH3 C triple bond CH, it is sodium metal. B, sodium liquid ammonia. C, soda amide. Tell me, you just write the product. Similar reaction, acidic hydrogen should be replaced by sodium. Next, this acidic hydrogen replaced by sodium, but here byproduct is H2. But ಇಲ್ಲಿ ಏನು ಬರುತ್ತೆ ಹೇಳಿ? What is the byproduct here? Hydrogen plus yeah, it is hydrogen also. Ammonia is okay, but here is ammonia. Next, so reaction with Tollens reagent, very very important. Let us take acetylene reacts with silver nitrate in presence of ammonium hydroxide, which is called ammonical silver nitrate solution. Okay, tell me, so acetylene plus ammonical silver nitrate solution. So what happened here? Acidic hydrogen replaced by silver? No. If you take 2 moles silver acetylide, it is also called silver mirror test. Next, E, so reaction with cuprous chloride, acetylene reacts with cuprous chloride, it is in presence of ammonium hydroxide only, ammonical cuprous chloride. Tell me, what is the product? So if you take 2 moles copper, either disilver, no, dicopper acetylide.